Hey, Dalal. Can you hear my audio? Just want to check to make sure you can hear me before we start up here. All right, thanks a lot. Hello, hello. All right. Um, okay, we can run through some of these. So fractions, if there's specific questions, I can obviously go through those. I just want to make sure you guys are all right. All right. Did you guys want me to make up some questions? I can add some stuff with fractions as well. Um, if you are looking for fractions for tomorrow, sure. I'm not sure how many fractions with six terms. I'm not. That's hard to answer. I'm not sure about that. But I can go through some examples of some fraction questions you might get on tomorrow's quiz. Hello, hello. Okay, I'll run through these ones here. Let's take a look. Someone had asked me some examples of fractions. Let's go ahead and take a look at this one here. Oh, Kinlon. Hello, Kinlon. Hey, Dia. Let's take a look at this one here. This 1/2 x minus 4, the whole thing squared. So like we had talked about, when you're tackling this problem, you want to square the first, right? So again, off to the side of your page, you can take a look at what is um, 1/2 x squared. When you take your exponent, of 2, that gets applied to each term here. So this power of 2 gets applied to the half, and the power of 2 gets applied to the x. So 1/2 squared is going to be a quarter, and this will be x squared. So if you square the first, you're going to get 1/4 x squared. Now if I go ahead and do the first times the second, it's going to be the first. And you can write it down if you need to. times the second. Don't forget to grab the sign in front. So first times the second, and then times 2. So again, when you're multiplying fractions, you want to multiply the top with the top, bottom with the bottom. You want to look to see whether you can simplify a bit here, and we can. Like these 2's cancel. So first times second times 2 is going to be minus 4x here. So this will be minus 4x. And then square the last, you get 16. Is this okay with the fraction one? Do you want me to give you a couple of these to try out? Like here's some other examples of fraction questions. Good, Dalal. Here, do you want to try like this one maybe? And this one might be a little more difficult. Okay, good. Yeah, try out number 2 here. And Dr. Saturn, I think that's Matthew. I can go ahead and take care of this cubic one you're asking me, if you want to check it out. Okay, so try number 2 here. I can do this one as well. This would be 2a cubed. This is to the power of 2. So the person looking for the 2a cubed minus 5b squared, the whole thing cubed, this is number 16, I think it was. Are you with me so far? Break it up into these two here, if someone could let me know. Power of 2, and then a power of 1. So I'm going to square the first here. This is going to be 4a to the power of 6. And first times second times 2 is 20. A cubed, b squared. Plus square the last, you get 25b to the power of 4. Yeah, there's a lot to do in this one. Okay, we can work on them. Dr. Saturn, you have not responded with this one, so I'm going to leave this here. Whoever was asking me that one, if you need it, let me know. We can load it back up. The fraction one here, let me take it up. Yeah, let's take a look. So if you go ahead and do this fraction one, this one is a little bit more difficult. So you're going to go ahead first and distribute the 1/3 x to this binomial. And then the minus 4 is going to go into this binomial, as you guys know. So 1/3 x times 6x. Again, off to the side of your page, you can take a look at that. 1/3 x times 6x is going to be, you multiply the numbers together, so 1/3 times 6 is 2. This will be 2x squared. So your first term is 2x squared. Then you're going to have 1/3 x times negative 1, and that's going to be negative 1/3 x. So you can write that down. Then I'm going to have negative 4 times 6x is minus 24x. And then lastly, you're going to have negative 4 times negative 1 is 4. Good so far? So now that I've expanded it out, you're looking to collect like terms, and this is probably where Nicole was having trouble, understandably so, is you're taking a look at this negative 1/3 x minus 24x, because those are like terms, but you have to get this together. So you're going to have to go ahead and get a common denominator, because to add like terms, you add the coefficients. So in this case here, I've got my minus 1/3 minus 24. And I want to like put that together. So this is minus 1/3 minus, you're going to have to get a common denominator. So I'll have to multiply top and bottom by 3 here. Let me just make it so you can see this a bit better. All right, so this will be minus 1/3. So the numbers are a bit messy here, but this will be 60 and 12. So this will be minus 72. Minus 72 over 3. Do you see that step there? So this would be minus 73 over 3. So this is 2x squared minus 73 over 3x plus 4. Not the nicest numbers. All right. I'm so lost. What just happened? Do you want to try another? We can make up another here with fractions. Okay, let's try another one here. Let's look at another example. And let me change this just so the numbers are a little bit smaller on us. Let's do that. Okay, do you want to try? I'll let you guys try this one out here. Okay, so if you want to expand this out, you're going to go ahead and do 1/2 x times 4x. Okay, you'll have to wait now. So for this one here, if I expand this out, we're going to get 1/2 x times 4x is going to give me 2x squared. So this becomes 2x squared. Then we have 1/2 x times 1 is 1/2 x. Then we're going to have minus 1 times 4x is negative 4x. And lastly, negative 1 times 1 is minus 1. Good so far? So I went ahead and distributed the half into the binomial here. So you end up getting here 1/2 times 4x is 2x squared. 1/2 times 1 is 1/2 x. Minus 1 times 4x is minus 4x, and then minus 1 times 1 is minus 1. So again, we're in a situation where I have a common, like, like terms here. I have to put these together. But that means I need to know what is 1/2 minus 4. So back in grade 9, grade 8, whatever, you have to figure out what is 1/2 minus 4. Right? Those are like terms. I have to put them together. So I need a common denominator. So this will be 1/2 minus. This is over 1, so I have to multiply top and bottom by 2. That's going to be 8 over 2. And this is negative 7 over 2. So the value is negative 7 over 2. So this is 2x squared minus 7 over 2x minus 1. Good, good. Dalal, is this better? Nicole, is this okay? Fractions was not like a big part of our homework. It did pop up once, so you'll probably get something with a fraction on tomorrow's test, but it's not a massive part of the test. Did you want me to make up some questions that you can work through? Or are there specific questions? I'm going to help Lena. Sure. And I'll work through this question here as well that I was talking about. But yeah, I'll give you some to try. Sure. Let me make up some. All right. 2x plus 1 times 5x minus 3. And then let's do like a negative 2 times 5 minus 4t times t plus 1. Something like that. And then maybe sure. Okay, here's 5 of them here. Hey Jack, I'm doing good. How are you doing? AZ. Oh, if you have 5. Oh, sorry, I missed your question there, Humdi. If I have 5b squared, how would you complete it? Oh, that'd be 25b to the 6th. Here, let me do that one for you. Oh, jeez. Okay, I just have to make some room here. Oh, isn't that tomorrow? Is that today? Is that right now? Hamdi, for your question, just to make sure, I just want to make sure I'm answering your question. This is 5b cubed to the power of 2 is 25b to the power of 6. Okay, so I'll let you guys work on these 5 here, and I'll help, I think it was Matthew, with this one here. So square the first, check, we got that. First times second times 2, we took care of that. And square the last, we get this one here. And then I just wrote that back down. So now I have to go ahead and actually distribute this. So I'm going to have to take, in this case, the 4a to the power of 6 and multiply it by both of these terms here. So that's going to give me here 8, a to the power of 9 minus 20, a to the power of 6, b to the power of 2. And then we're going to go ahead and take a look at the next one. And I'll multiply by these two now. Yes. So now the next one will be negative 20 times 2 is negative 40. And this will be a to the power of 6, b squared, plus 100, a to the power of 2, b to the power of 4, plus 50, a cubed b to the 4, minus 125 b to the power of 6. So all this ugliness expanded out and got this here. Now we do have some like terms with this one here. I'm noticing here I've got a to the 6th b to the b squared, a to the 6th b squared, and then I also have 100 a cubed b to the 4th, a cubed b to the 4th. So those are like terms. I can put those together. Minus 60 a to the 6th b squared, plus 150 a cubed b to the 4, minus 125, oops, that is an ugly 5, minus 125 b to the power of 6. And that's the answer for this one here. Not a pretty question there. Is this okay? All right, let's take a look at these numbers 1 to 5 here. I can take some of these up here. All right. All right, I'm just making a bit of room here as I go through these. Okay. Okay, so for this one here, if I expand this out, you should have gotten 10x squared minus 6x plus 5x minus 3. And the answer was 10x squared minus x minus 3. Good, good? So same strategy with number 2, and we had talked about this. The coefficient in front you save for the end. So for this one here, you're going to put that 2 down, and you're going to go ahead and expand out this, the product of this binomial here, to which you get 5t plus 20 minus 4t squared minus 16t. No, of course not. It doesn't matter, Nicole. You can put the 1 in front. Makes no difference. And then always want to collect like terms. So before you distribute, you should collect like terms. In which case I get here negative 4t squared. And you get 5t minus 16t is minus 11t plus 20. And then distributing the 2 is 8t squared plus 22t minus 40. Is this okay? I'm just doing binomial expansion questions. That's kind of what we're working on now. Is this okay so far? No. 3 here, I can take up 3. So if you're tackling number 3, again, you want the coefficient for the end. So what I'm going to do here for number 3, if you take a look, is I write down that 2, and then you go ahead and expand this out. So you're going to square the first. The first times second times 2 is going to give you minus 30t. Plus square the last, so you get your 9. Then you're going to distribute that minus t into the brackets. Right, so now I've gone ahead and I've expanded this out. You should always look whether you could simplify. I don't have to simplify it in this case. And then you're going to distribute this 2 into the brackets. So I'm doubling all of these numbers. So this is going to give me 50t squared minus 60t plus 18 minus t squared minus 6t. So this is going to give me 49t squared and minus 60t minus 6t is minus 66t plus 18. So that's the answer for number 3. I'm not doing any factoring now, but if you want me to factor that, sure. I'm not sure what class you're in, but if you want this factored, we're not there yet, but I'll factor this quick for you. Is this good, numbers 1 to 3? We're okay? Oh, I think my screen's cutting some of that off there for you. Is 3 all right? The person who asked this one, just because my class isn't responding, I answered it. I just treat it like a quadratic here and factored it. 2 numbers that multiply to be negative 12 add to be negative 1. And then you have difference of squares. Oops, sorry. You have difference of squares here. Lena, sir, whenever we solve a problem, do we always have to use a quicker method? You know, you don't have to, Lena, but like you should do that though. Like you should try to do that because it just makes it a lot easier in the long run. Like, you know, I'll keep using it throughout the year and you'll end up probably doing it as well. But it will make things a lot quicker for you, especially when you get to the higher grades. Yeah, anything can be on the test, Nicole, for sure. So number 4 here, I can answer this one. You're going to distribute. You're going to distribute. So x times x is x squared. Then you've got here, if you take a look, I've got x times negative root 2. That's going to be negative root 2x. Then you've got root 2 times x. That's going to be positive root 2x. And lastly, root 2 times negative root 2 is minus 2. So this becomes x squared. These cancel. And this is x squared minus 2. So the answer for this one was x squared minus 2. There's roots in the homework, so there could be roots on the test, yes. Is this okay? Who is anyone done number 5? Like they've worked through number 5? No, no. The variable first is not wrong. You should try to. You should try to put the number first. You should try to put the number first, but it's not wrong if you do that. It just makes it kind of easy to make a mistake. Hey, Hey, can you do bracket acting polynomials, please? I'm not sure. What do you mean by bracket acting polynomials? Can I do synthetic division if the denominator or the number you're dividing by has more than 2 terms? Synthetic division's for linear terms, so it's only for like things of the form like mx plus b. It's got to look like that to do your synthetic division. It's got to be a linear root. So you can't do anything that has a degree less than 1. For my class here, are we good with 5? Is anyone still working on 5? I'll just kind of take up 5, I suppose. Oh. Yeah, you need, for your question, you just... Sure, we can make up something with monomials as well, for sure. For 5 here, if you do go through it, the idea with this one is you want to clean this up, so you tackle these as separate problem, right? The reason I put this question is this right here, a lot of times students want to make that a 3. And you can't do that because you have to apply your bedmass rules, right? You have to go through your bedmass rules. So you have to take care of brackets first, to which there's nothing to do in the brackets. Then you have to take care of your multiplication, and the operation here is multiplication. So it would be incorrect to write this as a 3. Like you cannot put a 3 here. The reason for that is you have to follow your bedmass rules. So I just wanted to point that out. That's why I kind of made up this question. I like that. You have to distribute your minus 2 into your brackets first, because multiplication is going to happen first. So you get your minus 2x squared minus 6. This here, like we talked about, you're going to go ahead and expand this out using your FOIL. Like just you're expanding your binomials, the product of these two binomials first. And then now I can kind of jot this all back out. And then before you distribute, you should always simplify. And then I can distribute the 4. So it becomes 4x squared minus 4x minus 8. Right? Good, good. And then from here we can go ahead and collect like terms. So this is a like term with this one. That becomes 2x squared. And minus 4x, I guess I just write that down. And then my other term here is 5 minus 6 and minus 8. And you can put all those together is going to be negative 9. And that's the operation for number 5 there, or the solution for number 5. Operations on monomials, addition and subtraction. Like when a monomial, like we did some binomial multiplication, but if I guess we could take a look at that. You know, you can be asked stuff like, you know, a monomial times a binomial, right? We can look at operations such as this, or you can put like you know, minus x times x squared plus 1. Actually, let's do 2x plus 1 squared. This is another operation we can work on. Sure, number 5, here you go. Okay, there's 5. here to answer your question. Yeah, if you are doing synthetic division, if you're looking to break down the polynomial, you can do it using long division. Like I see you asking this. What is this? 7x squared plus 5x plus 3. You can do it doing. You can solve it using long division. Like you can break it down using long division like this, or you can do it using synthetic division. Synthetic division, you'd have to take a look at the roots here. But and you get the same answer. So you can do it either way. You'll get the same result using long division or synthetic division. For those of you asking. Are we good then? For my class here, are we okay? Is there anything else that you guys need from me? Yes, Kinlon, what's up? Yes. I'm ready, Kinlon. Is the remainder relevant to my answer? Well, it depends what you want from your answer. What's the question asking? Just to divide it out? No, it's all right. What do you call a mouse that swears? What's the? Sure. No, not at all. Okay, so a square root question. Oh wow, that's a good one. Okay, I'll try that tomorrow, Dia, with my class. See how it goes. A cursor. That's really good. Better than the jokes I've been getting. No luck, Dia. All right, let me try this next one here. What is? Humdy, my grade 12s always laughed at my jokes. I don't get no luck with my 10s. All right, we've got here number 9. Yeah, just to answer your test question, you're asking me to go through long division, right? So I did it using long division and synthetic division. And then you're asking, yeah, the remainder is relevant to your answer. Just let me answer this, and then I'll get to the questions here. So this is your polynomial. So you get your polynomial is equal to the quotient times quotient times divisor, and then plus your remainder. It's your division algorithm. Same thing can be said with this one. All right, I do have to answer my class's questions now. So Dalal does not. Why did the Scarecrow win an award? I do not know, Kinlan. I'm ready. Okay, number 9. I just gotta like grab number 9 here. I'm trying to find it. Just give me a moment. Oh, okay. Here's number 9. Who was asking number 9 here? It is 4x squared minus 1/2 y times 3x plus 1/4 y. All right. Thank you. All right. Is this good for number 9 here? Oh, because it was outstanding. That's good. I'll try it tomorrow, Kinlung. I'll let you know how it goes, but I have not been lucky with these. Grade 10s don't laugh at my jokes as much as grade 12s. All right. So we're going to distribute that into here. Okay. So whoever asked number 9, I can go ahead and do it. You did, I know. So this one here for number 9, it's going to be 4x squared times 3x. You're going to get 12x cubed, the person who had asked this. Then you've got 4x squared times 1/4 y. The 4 and the quarter will cancel. You're just going to get x squared plus y. And the reason for that is it's 4x squared times 1/4 y. So again, multiplication is commutative. So this 4 and a quarter come together to just be 1. So it cancels off. And then likewise, if you take a look, I have minus 1/2 y times 3x. So that'll end up being minus 3/2 xy. And then lastly, minus 1/2 y times 1/4 y is minus 1/8 y squared. Minus 1/8 y squared. And that's it for this one here. Is this okay? And who was asking number 9? I got the minus 3/2 xy because I took the minus 1/2 y times 3x is minus 3/2 xy. Right, the reason for that is minus 1/2 times 3, that's over 1, so top with top. Oof, the 3 is terrible. Top with top and bottom with bottom, you get your minus 3/2. Oh, you got it, Nicole? Good. Good, good, good. Sure. Let's try with the root in front. Let's do like root 2x minus 1 times x plus 3. If you'd like to try that one with the square root. Sure, Nicole. Let me just copy it, and then I'll get back to that one there. Okay, there's the one I made up. Yes. So for this one, this is going to be root 2x squared plus 3 root 2x minus 3. Oh, this is okay. This one came out a little more difficult than I'd give you guys, because you end up getting this thing here. This is a like, these are like terms, so you have to put them together. So this would actually be 3. Oops, sorry. This would actually be 3 root 2 minus 1x minus 3. That came out too difficult. That example with the root there, because we haven't really talked about putting together like an irrational number and a non-irrational. That's what you get for that one. For this one here, number 6, since Nicole was asking, we can distribute the 2x into the binomial. I'll get 6x squared minus 2x minus x, and then you can expand this out. You square the first, you get 4x squared. First times second times 2, you get 4x plus 1. And this is 6x squared minus 2x minus 4x cubed minus 4x squared minus x. In which case here, then I have some like terms. I have this one and this one. And I have this one with this one. So this ends up being minus 4x cubed plus 2x squared minus 3x is your answer for this one, number 6. Sure, Evan. So for this one here, you're going to square the first. So if I square the first, I'm going to get 1/4 x to the fourth. Right, then you're going to do first times the second. So there's a lot going on in this one, times 2. So first times second times 2, you're just looking at the numbers. So I'm looking to take, in this case, a half times minus 3/5 and then times 2. So if you do all that, that's over 1. You should simplify, like the 2 and the 2 cancel. So this ends up being minus 3/5 is the coefficient. So this will be minus 3/5. And then you put your variables together, x squared y. And then you square the last term. So minus 3/5 y squared is 9/25 y squared. Is that good, Evan? No problem. Okay, are we good, guys? Ready for tomorrow? Are there any other questions? All right, if there's no other questions, I'll end the stream. You can kind of check out the work that we did if you jumped in late. You should be able to see some of the stuff we did. And that is it. All right, guys, thank you.